Hello everyone, how are you doing today? Good morning to some of you, good evening some of you. I hope most of you are in the morning time. Welcome to the Miss Pamela's radio station. Okay, so I hope you're not going crazy by now. Remember that we're almost done for this part of the week, and then we will start with our vacation mode. That will be super cool. You can watch all of documentaries in Netflix and stay with your family and
Play game board.
chat with your friends and a lot of stuff you can do. I know some of you are like really want to leave, but don't forget, stay at home and stay tuned. Okay, guys, I'm really joking a little bit with my class because I want you to smile. I want you to enjoy this time that you'll be watching my video, and I hope if you have doubts, just let me know. Okay, I'm really missing you. I hope you are missing me too, a little bit at least. And well, I'll continue. So remember before we were talking about work and power and how from that all machines came. Okay, now we said that in order to have work done, we need distance to be involved, okay? So this is what I want to start with. Now we will start talking about understanding machines. I won't ask you, what do you picture when you hear the word machine? Yeah, I know, no one will answer because we're not online. So let's go to the next slide. I don't want you to be fooled with all of this information. You do not need to learn anything by heart, because right now I want you to have the theory about simple machines, understand them, understand some concepts, and then when we come back after vacation, we'll start with the problems, okay? Let's have it clear that machines help us do work in an easier way, okay? And they can help us through three different factors, which are the amount of force you will exert, that will be less, the distance over which you exert your force, we'll see some examples later, and the direction in which you exert your force. If you apply your force pulling, the object will be pushed, or the other way around, okay? Now we have two concepts here called input and output force, okay? You already did these key terms before. And these two words are important. In order for a machine to work, simple machine or compound machine, it needs a force to be applied on it. Okay, so work can be done. Now, the input force, for example, will be the force that is applied into the machine, the one that you as a person or another machine will insert or apply that force to the simple machine. And the output has to do with the outcome. Okay, the outcome force, what it makes it like at the distance covered at the end, or the force covered at the end, etc. Okay, here I have a short example where you have in an inclined plane. You already know more or less what an inclined plane is. If not, we'll see it right now. And the input force is applied right here, and the output force will be up here. Okay, so that's more or less to understand this concept. As I said, you don't need to super clear it, but understand a little bit this concept, okay? And we also have the input work and output work, and just as we know that work equals force times distance, right here the same. The output work equals the output distance times the output force, and the input work, input force times input distance. Stuff that's kind of obvious. Now, the three factors that I was talking about before, for example, changing the force in this one. This small pivot right here, if you would use your two fingers to move it, it would be super hard. That's why they have this thing here to make it turn and make the force being increased, okay? This is the example of the first factor. The other factor would be the chopsticks and changing the distance. For example, in this part right here, you're applying the force, and this part right here, you're taking in this case, the sushi, okay, or the rice. Another example would be, for example, a shovel. Your force, you're here, and you have the shovel right here. So you apply the force here, but the object that you're moving is at the bottom. That's another example. And then you have changing direction, which is like kind of a pulley. If you apply your force downward, the object will move upward. Okay? So these are the three factors. Now let's move to what mechanical advantage is. this is a very important concept that we need to know. Mechanical advantage is the number of times a simple machine helps you to do work in an easier way, okay? Each simple machine will have its own formula also, but I will not talk about it right now, okay? But it's the ratio, or the number of times, as I said, okay? And I will give you a very short example. For example, you exert an input force of 10 newtons to a can opener, yes? And the opener exerts an output force of 30 newtons. Can you imagine you moving the can opener, like applying a small amount of force, and it is applying, and the outcome is a bigger force? Okay, so you have 30 newtons that you have as an output, and 10 newtons that you applied. So this one is helping you 3 times. So the mechanical advantage is helping you 3 times. It's like having 3 U's, like 1 Miss Pamela, 2 Miss Pamela, 3 Miss Pamelas moving it at that force, and it's like helping you, okay? And efficiency is dividing the output work by the input work and multiply it times 100, okay? And now we won't do problems of efficiency right now. And well, that's for machines, and the most basic device to making work easier are called simple machines. And by now you have heard the simple machines rap, right? I hope you liked it. It's kind of sticky, that song. I loved it, and I hope you remember it sometime. Okay, sorry, my microphone fell. Okay, now let's start with the inclined plane. The inclined plane helps you to move in a longer distance depending on how inclined it is, the inclined plane. Okay, please stop this video and watch the inclined plane video that are in the instructions of this classwork. Okay, now let's talk about the wedge. A wedge is a simple machine that is thick at one end and thin at the other one. Now, if it's thinner, it has more mechanical advantage. It helps you more. For example, think of knives, okay? Which knife helps you more when you are, for example, chopping lemon, okay? The one of the butter or a really, really thin knife, okay? Please stop this video and watch the correct video assigned on the classwork. And now let's talk about the screw. The screw is an inclined plane wrapped around a cylinder. Now, I forgot to mention, you guys, that there are 2 members in the inclined plane family, which is the screw, because it's an inclined plane wrapped on a cylinder, and the wedge, which is a small inclined plane moving, and you can move it, okay, with your hands. A big inclined plane, obviously you can't move it unless you have another machine to move it. Okay, and please stop this video and watch the screw video. Okay, here I added some examples of screws. I hope you understand them better. And then we'll start with levers. Please stop this video again and watch the video. Okay, now about levers, guys. There are 3 classes of levers, okay? And what do I mean with this? That the fulcrum, that like you saw in the video, the fulcrum or application point is where the lever pivots, okay? And we have 3 classes. In one, the fulcrum is in the middle. In the other one, the load or the object that you want to move, as you can see here, is in the middle. And the other one, the force, is in the middle. Now, right now, you do not need to learn them, but I want to show you what's the difference between them. The first class lever, guys, is the one that the fulcrum is in the middle, okay? The force is in one end and the load or the object that you want to move is in the other end. For example, let's observe this one. Sometimes you've seen at home that you want to open a paint can with a screwdriver, okay? And right here, from here to here is the resistance, because it's the lid, what you want to move. Then you have your application point or the fulcrum here, and then the force is applied right here. If you can observe these tweezers, the object that you want to move, for example, a screw, would be right here. The fulcrum is right here, and the force is applied right here. The same in this one, that also can help you understand it as a shovel, pulling out a nail with a hammer, and the scissors, okay? Here is, for example, the paper, the fulcrum, and the force applied. This would be the first class lever. Then we have the second class lever, where the resistance or the object that you want to move is in the middle, we have a nutcracker here, application point or fulcrum, the object that you want to move, which is the load, and the force is applied right here. Or in this one with the wheelbarrow, the force is applied right here. The fulcrum or application point is right here. And I don't know why it says here force, but it's not force. Here would be the load or resistance. Okay? And then we have the third class lever where the force is in the middle. We have a broom. We have some tweezers, for example, in the one of the bread or the carnita asada. Here you have your bread or the carnita asada, as I said. And object that you want to move, the force is right here and the fulcrum is right here. And you can now guess how this one works from here to here, this one and this one, okay? And then we have wheel and axle. Please watch the corresponding video. Then we have pulleys. Also watch the corresponding video. And for pulleys, you don't know, but I was super excited because with Professor Israel, with the carpenters at school, they built me some pulleys so I could teach you how they work, how mechanical advantage works. It's the first time I ever had something done for this lesson, and I couldn't use it. I really hope next year we can use it or when we come back. Okay. We have a fixed pulley. The fixed pulley is, in Spanish, fixed, if you already know, is fijo. It's not moving. So this one is right here. And it's just like a piñata. Okay. The mechanical advantage of this one is 1. So it is helping you only 1. But teacher, how come it's a simple machine and it's helping me if it's only helping me 1 time, not two or 3 like the can opener? Well, because for example, imagine lifting a barrel instead of pushing it upward. It's easier to pull down because you apply all of your force that comes with your body downward, and it's easier. That's why. Then we have a movable pulley, and this one, the movable pulley, has a mechanical advantage of 2. We'll see the problems later on. And an excellent example of this would be a zip line. Okay. And then we have the movable pulley. We're still on the movable pulley. I'm sorry. Okay. This is another example of the movable pulley. Here we have a crane. Here we have, this one would be the movable pulley, and it's with a fixed pulley, but you count this one right here. Okay. And then we have the block and tackle. In Spanish, it's also called polipasto. Okay. When you are doing a CEP exam, it might come. And the block and tackle or polipasto has a mechanical advantage of the number of pulleys. For example, in this one, we have 1, 2, 3, 4. So my mechanical advantage will be equal to 4. Okay, you can see the drawing, or in the problems, I'll be telling you the amount of cables or the amount of pulleys. In this one, we have 1, 2, 3, 4. Again, okay? But you can find an 8, an 18, a 12, okay? And if you have more pulleys, you'll have more mechanical advantage. You will apply less force, okay? And by now, this is it. I hope you enjoyed this video, and stay at home, stay tuned, enjoy your days, play some board games with your family. I love you guys. I miss you, and I really hope to see you soon. Kisses. Bye.